Okay, in this class we discuss about the LR parsers. Okay, so first because they are very important for the examination point of view, so I have taken first them. So coming to the LR parsers, we are having total 4 types of LR parsers. Okay, so one is LR of 0, SLR of 1, LALR of 1, and then CLR of 1. Okay, so actually these are what type of parsers? They are the bottom up parsers. Okay, they are the bottom up parsers. Okay, now now coming to the so I have taken here most powerful parser. It means what? So SLR of 1 is more powerful compared to the LR of 0 parser. LALR of 1 is most powerful than the SLR of 1 parser. CLR of 1 is most powerful than the compared to the LALR of 1. That is what meaning. It means what? So it is going to identify the errors mean very accurately. That is what most powerful. Okay, so compared to this is going to find the errors. Okay, that is what a second phase. What is second phase? We have to find the syntax errors and we have to build the syntax tree, nothing but a parse tree. Already we have seen in the previous class. Okay, first phase is the lexical analysis. Okay, so what is the outputs? Stream of tokens or set of tokens. So this is given as input to the syntax analysis. What is the output I have to get? I have to get as a parse tree. Already we have seen. Okay, so this is what this is called parse tree. So in this phase I have to identify the errors, syntax errors. Okay, so after overcoming the syntax errors I have to build the parse tree. That is what the actual concept. Okay, okay, so compared to the LR of 0 parser, this is powerful. Compared to this is most powerful. Compared to this is most powerful. Okay, that is what here most powerful parser. Now coming to the what is the meaning of LR of LR? Okay, LR means what? First L is left to right scanning. Okay, so you take this string AABB dollar. So first you have to scan this, next I have to scan this, next I have to scan this, next I have to scan this. That is what left to right. Okay, left to right scanning. Second one what? It is rightmost derivation in reverse order. Okay, already you know about rightmost derivation in reverse. Okay, I will take example what it is meaning. For example, I am taking the string id plus id star id. Okay, so I have to reduce in reverse order. Rightmost means what? This is the rightmost. Okay, this is the leftmost. So these I have to first reduce. Okay, in the reverse, reduce f. Okay, again I am reducing f to the t. Okay, I am reducing this t to the e, then again reducing like this. So in this way I am moving, not like this. Okay, so in this way I'm reducing. So like this. Now what I'm reducing? I'm reducing this id to the again capital E. Okay, directly I'm taking here. So next one what? I am reducing this id to the this e. Okay, in this way I am moving. Okay, rightmost derivation in reverse order. It means what? The rightmost symbol I am reducing in reverse. Okay, that is what rightmost derivation in reverse. That is the meaning of LR parsers. Okay, so this is a what type of parsers? These are shift reduce parsers. Already you know. Okay, shift reduce. Okay, so it means what? We have to push, we have to pop. Already you know that term. Okay, so that is about the LR. Okay, L means left to right scanning, R means it is rightmost derivation reverse order. Okay, that is what about. Now coming to the, I will take first example, first type of parser, bottom up parser, that is LR of 0 parser. Okay, so 0 means what? I am not looking any symbol. Okay, simply I am building a tree. That is called 0. Okay, So 0 means what? Without looking any look ahead symbol, I am building the parser. So this you come to know when you complete the when you complete the SLR of 1, when you complete the LR of 1, when you complete the CLR of 1, then you come to know what is the meaning of 0 or a look ahead symbol. Okay, that is what LR of 0. Okay, you know about LR of LR means what? So left to right scanning, R means rightmost derivation in reverse order. Okay, 0 means I am not looking any look ahead symbol. Okay, that is, so this is the first question I am taking. Now coming to the diagram. So coming to the diagram. Okay, so diagram is the, so in this I am having stack. So stack is a data structure, okay, to perform shift reduce. Shift means push and pop. So input buffer what? I have to store the string. Okay, so to store the input string for scanning purpose, I am taking the input buffer. This is a algorithm. LR parser is a algorithm. Next one what? This is a parsing table. Okay, that is a parsing table. LR parsing table. Okay, now what we have to do? So coming to the to construct LR of 0 and then SLR of 1, we have to build LR of 0 items. Okay, to construct, I will see that LR of 0 parser. To construct SLR of 1 parsers, we have to build LR of 0 items. Okay, so to construct LR of 1 parser and then CLR of 1 parser, we have to use the LR of 1 items. So we have to know what is the item. Okay, so first of all we have to know what is the item. Okay, now I will give some idea. So directly I'm taking the example. So construct LR of 0 parser for the grammar. Okay, so what is the grammar I have taken? S tends to A tends to A, capital A, small b. This is context free grammar. Okay, so always you have to make note. First you have to construct go to and closure. Using go to and closure, I have to build the LR parsing table. So using this table, I have to build LR parser. This is what? First you have to construct go to and closure, then you have to build LR parsing table, then you have to construct LR parser. This is my output. Okay, so I am taking the example, then I will tell. So what is a go to, what is a closure, what is LR parsing table, and then how to construct LR parsing table, how to construct LR parser. Okay, first we have to see the item. Okay, so what is the item? So what is the item for for anything? Okay, so for any production. So S tends to, I'm taking one example, S tends to, you see, AA. So in the RHS, if you add dot, this is called item. Okay, this is not an item. This is not an item. So you are adding a dot. You are adding a dot to the in the RHS. This is called an item. Okay. For example, if I add A tends to dot B, this is an item. Why? Because in the RHS I am adding the item, I mean dot. Okay, anywhere, it may be here, it may be here, we'll see that. Okay, that is what item. Okay, now coming to the what is a reduce, mean what is reduce. Okay, see, it means, for example, if I write here, if I write S tends to dot A. Okay, S tends to dot A, it means I did not look anything. Okay, now if you write S tends to A dot A, I look A. Okay, I have seen. Okay, or you write I have seen A. Now if you write S tends to A dot, I have seen everything. I have seen everything. That is what meaning here. So what is I have seen everything? It means, okay, if I have a I am able to reduce to s when you see everything. That is what meaning. If I see completely a, okay, if I see everything, then only I am able to reduce a to the s. So it means I am able to reduce a to the s. That is what reducing. Okay, that is what reducing. Okay, okay. For example, now you see here for the grammar. Now for the grammar, so understand. So what I'm telling, this is very important. Okay, dot a, I didn't see anything. If I write s tends to a dot a, I have seen a. Okay, I have seen a. So s tends to a dot, I have seen everything. So it means what, when you see everything, I am able to reduce to the s. That is what. If you take one more example, see, if I write, if I take B Tech, so when you are in the first year, write what you write, 1 2 3 4. It means what, this is an item actually. You have not completed any 1 year. When you write 1.234, it means what, I have completed first year. Okay, when you write 1 2 3 4, I completed first year, second year. That is what meaning. So when you write 1 2 3.4, not point, it is dot. So I have completed first year, second year, third year. Still what is pending? Fourth year is pending. So 1 2 3 4. When you complete everything, what you get? You get the BTech degree. That is what I have seen. Okay, I didn't see anything. I have seen one. I have seen 1 2. I have seen 1 2 3. I have seen 1 2 3 4. I have seen everything. So I am getting the BTech degree. That is what here I am seeing like that. Okay, okay. Now you have to know one more thing. So argument grammar. So now I will take how to see. First of all, what you have to construct. See, this is it. So they will give like this. You have to construct go to and closure. Next you have to construct this table. Next you construct parser. First I am taking the go to and closure. So for this grammar, okay, so I am writing the grammar. Okay, no, if you want it, no need. So directly I am taking, you have to create argument grammar. It means, first, what is an argument grammar? For existing grammar, I am adding a one new rule, that is called argument grammar. It means s dash tends to s. Now s tends to a. Okay, so a tends to a, write separately for convenient purpose. A tends to b. So this is called argument grammar. Okay, it means using existing grammar, I am adding a one new rule. What is the new rule? S dash tends to s. Then you write remaining also. S tends to a tends to a tends to b. This completely is called augmented grammar. Okay, now build go to and closure. go to and closure. I will tell what is a closure, what is a go to. Okay, so here I am writing go to and closure. First you take this rule, write like this: s dash tends to you add dot s. Okay, because I am having a dot to the left of s, you add all the rules of s, this. Okay, s tends to dot aa. Again for the left of a I am having the dot. Now add the all the rules of a. Okay, this a tends to dot aa, a tends to dot b. You name it as the I0. Okay, I0 item. That is what closure. Okay, what is the closure? So s dot, first of all I am taking the first rule, that is s dash this. What is the closure? So the rules of the s you are adding for in this remaining. Okay, because there is a left is dot to the s, you have to add remaining rules, that is called closure. Okay, now you have to perform go to operation. Okay, now this is go to. Okay, s dash tends to s dot, you name it as the I1. It means what is a go to? I am moving this dot to the right of it, that is called go to on s. Okay, what is the closure? Whenever there is a left, whenever there is a dot to the left of s, I have to add all the productions. Again for the left of a, the dot is presenting in the left of a, I have to add all the rules of a, that is called closure. What is a go to? When I move this dot to the right of it, that is called go to. Okay, next. So this is over. Now take this rule, now take the second rule. Now perform go to operation. So this a, I have to move this dot to the this place. S tends to a dot a. Okay, because there is a dot to the left of a, I have to add all the rules of a. A tends to aa, a tends to dot b, you name it as the I2. Okay, now so this is over, this is over. Now this, so what is a go to? I am moving on a here. Okay, so then a tends to a dot a, because there is a dot to the left of a, I have to add all the rules of a. Okay, then a tends to like this, a tends to and then dot b, then give the name I3, give the name I3. Now what is the pending? This is also over. Now we have to go for this, perform the go to operation. B, a tends to b dot. So this is what it is, I4. Okay, this is I4. Now see, always make a note here, you can't do anything. Why? Because the dot is at the rightmost, you can't do anything. This is called final item. Okay, so here you can't do anything. It means you are unable to move the dot somewhere. This is final item. Now you take S2. Hmm? Now move the dot to the right of A. Then A, S tends to A dot. So no need to add any rules of A. Why? Because there is no any variable here. This is final item. You name it as the name as a I5. Now you take this one. Okay, you take this one. So write separately what I'm getting for this. So this is over. Now take this one. So A tends to tell me what I'm getting for this. A dot A. Okay, I want to add all the rules of A. A tends to, okay, so and then A tends to dot B. See, by observation, this is same as this. Okay, this is same as this. Then what you write, simply do like this. Okay, now again what is pending? So this also over. Now we come to here. A tends to B dot. Now where I have to go? Simply take a arrow like this, B. So I0 is over, I1 is over, I2 is over, I5 is over, okay, I4 is over. What is the pending? I3 is pending. Okay, now what you do? So I want to take go to on A, then what will be the output? A tends to, okay, A dot. It is, name it as a I6. Now what is it? This is over. Now what I have to do? Now when you perform the go to on small a, you get this self loop. Okay, it means what? I'm getting the this same. Simply give the self loop. Now what? So on this also a tends to B dot. Now simply give the arrow like this. So these are called LR of 0 items. Okay, so what I told in the first two thing. Okay, so LR of 0 items. LR of 0 items means, so these are LR of 0 items. So in this way, how to build the LR of 0 items. Okay. Now take a grammar. So what? So construct the LR of 0 parser. First, what we have to do? We have to construct go to and closure. It is over. Second one, what? We have to build the LR parsing table using go to and closure. Okay. Okay. Now write a table like this. You write table like this. Okay, you write table like this. So what is I0, I1, I2, I3, I4, I5, I6? They are the items. So I0, I1, I2, I3, I4, I5, I6. You write in the table. Okay. So there are two columns will be there. One is action. Second one is the go to. Okay. In the go to you write variables. So A and S. So what is A and S? They are the variables in the grammar. Okay, A and S. So what is A, B, dollar? So A is a terminal, B is a terminal, you have to add a dollar. Okay, now what is I0? Now how to fill? So I0 on capital S. Okay, I0 on S, where I am going 1. You write 1 here. Okay, now sorry, I0 on is I'm going to the 1. I0 on A where I'm going 2, I2. Okay, you write 2 here. Now what about small a? I0 on small a where I'm going to the I3. You write S3 here. Next I0 on B where I'm going to the I4 means S4. Okay, like that. Okay, so whenever there is a capital letter, I'm writing numbers I2 1. Whenever there is a terminals, I'm writing the S3 and then S4. Shift. S means shift. Okay, now fill for the I1. What is the I1? It is a final item. Simply you add I1 on dollar, you write accept. Okay, you write accept. Next, what is the I2? So I2 on A, it is 5. It is 5. What is I2 on AB? So I2 on small a, it is S3. So I2 on small b, it is S4. Next I3. So what is I3? I3 on A, 1 second. Okay, so I3 on small a, it is S3. Okay, next I3 on small b, it is S4. Okay, so I3 on A, I3 on, it is capital A actually. Okay, I3 on A, it is 6. Okay, I3 on A, it is 6. Okay, now what about I4? What about I4? So I4 is, it is a final item. Okay, what is a I5? It is a final item. What is the I6? It is a final item. What is a final item? So when the dot is present at the rightmost, that is called final item. Then you take the grammar. So what is the grammar I am having? S tends to A, give some number 1. A tends to A, give some number 2. A tends to B, give the number 3. So when there is a final item, okay, so now where is the final item? So S tends to A, it is R1. Where I am having? I am having in the I5. Okay, so in the table I5, you write R1, 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 reduce. What about I4? It is A tends to B dot. What is the rule number? 3. You write R3. You write R3, R3. You write R3. Okay. Next. So what is the I6? It is number equal to 2. 2 means what? You write R2. You write R2, R2. You write R2. Okay. So this is the LR of 0 parsing table. Okay, So shift. So R3 means reduce. R3 means what? So I have given number 3. So rule number 3, reduce. Okay, so why it is a R3 under I4? Because in the I4 I am having the final item, nothing but a R3, reduce. Okay, in this way you have to build the LR of 0 parsing table. So using this parsing table we have to construct a parser that we will see in the next video. Okay.